I think it's doing it. Cool. All right, so we are starting section 2.1 on functions. And again, the hope is that you complete the notes while you're watching the video. He talked about when you see this little guy, that's good. Oh, by the way, if you have a question, please shout it out. Unmute yourself and let me know. All right, at any point in time as we go through this. So you've got this function intro. The guy, when you see the guy, he wants you to pause the video and try the problem on your own. There's something that we're going to do with graphing calculators, and he did a whole thing with a TI-83 calculator, but we don't have them, right? If we were in the classroom, we would. But we're going to use Desmos to do what we're going to do today. So we're going to come back to Desmos in a little bit before we leave this lesson. So he talked about a function machine. He put people in and people out, and he was trying to show you that what works to be a function and what doesn't work to be a function. And sometimes that's really confusing for kids. And so I'll give you the math gobbledygook, and then I'll put it into English for you, okay? Over in your margin, you want to say the same x or input can't give you different y's. Or outputs. So in your margin, the same x or input can't give you different y's or outputs. And I know that like I get confused, like is it the x's or the y's that can't repeat, right? Because all of us kind of say the same, they're just too similar. So what I do in my head is I remember two graphs, and here's the graphs to help me to decide what's a function and what's not. And again, we're still in the margin. So if you think of the x squared graph, can you think about what that looks like if I'm just an x squared? Any thoughts? It's been a while.
Just a straight line from...
That's a great guess. Awesome guess. If it were a straight line, it would be something that would be like a y equals mx plus b form, like y equals 2x plus 1. That would be a line type of thing. But you're on the right road. You're exactly on the right road. If I have a square, then I'm a parabola, right? And I'm a happy parabola. I'm smiling. I'm like this. This is my deal. I am happy. I'm going to give him eyes. Because he actually is a function. So if you're anything, because see, every x value I have has its own unique y value. Even though the y value might be the same over here, this x has a specific y value, this x has a specific y value. It doesn't have two or more than one. So he's a happy function. But here's the deal. He's had a rough week, and this has been a rough week, all right? And he suddenly falls over and goes like this. And now he's sad. He is not a function. This one is not a function. And the reason why it's not a function is because you see if you have an x value here, how many y values do you have? You've got two different y values. And so that's not going to work. So for me to keep it straight, if I think about it visually, this guy, I can have, all of my x's have their own unique y's, but this guy, my x value is giving me out different y's, and that's a problem to not be a function. So then he went on real quick to these charts, and he said, all right, are these functions or are they not functions? And so really what you're looking for is, do you have a repeating x? Is there an x that's, because it's all determined by what the x is doing. So if I'm looking at this guy, and I know he did this with you, you got -2, 25, -2, 13. You've got the same x giving you different y's. This guy is not a function. By the way, a couple things. You can, if you can't print these notes out and you want the printed notes, send me an email and I'll send you the units worth, I'll mail them to you, the units blank notes. Or you can just do them on regular loose leaf paper if you can't print them out, so it's really not a big issue with that. So either way is going to be fine. So if you can print them out, great. If you can't print them out and you want them, email me and I'll mail them to you. Or you can just do it on loose leaf paper or any kind of paper. All right, this guy here, do I have any repeating x's? And I don't, so he's a function automatically. Even though the y's are repeating, that's okay. Over here with this guy, you've got 13. You've got 13, but they're giving you the same y values out. They're not changing. So that means that this guy is also going to be a function. So from a chart, that's what you're looking at. Then he talked about input values and output values, or independent and dependent variables. The independent are mostly the domain, which are the x values. Domain goes with x, range goes with y. Then he went on to function notation. This is an example of function notation. F of x is how it's said, is an expression in terms of x. The name of the function, you put the input value, and then you get your output variables, your input variable, output variable, and then he got to these problems. Now these were pretty quick. All you're doing is plugging in the number. He showed you the work for that. This one might have been a little dicey. I think I might want to go through this one with you real quick. And then this one over here, you said, yeah, it doesn't really matter what you're putting in there. It can even be a smiley face. So this one was a smiley face squared minus a smiley face, and then a +1. So let's take a second. If he ran through this relatively quickly, so I want to try to make sure that he didn't lose you in the midst of plugging this in. So now we're taking this whole 2x minus 1 and plugging it into the x's in my function right there. So if I do that, I'll have 2x minus 1 squared minus, and parentheses are hugely important in the midst of this, so keep the parentheses there. 2x minus 1 and then a +1 at the end. And then you've got to think about, please excuse your dear Aunt Sally, right? Remember that whole thing? So you got to do exponents before you can do anything else, so I'm going to deal with this. It really means I have two of these things, 2x minus 1 and a 2x minus 1. They're multiplied together. And if I bring along the whole rest of this hot mess, here it is. But it brings me to the fact that I need to FOIL. So I don't know if I know it's been a while since you've mathed. So let's talk a little bit about FOIL, and I'm going to come up here to a space I have. When you FOIL, I'm going to introduce you to Mr. FOIL Man. This is probably an Algebra 1 type thing, but anyway, we can handle it. If you do the firsts, the F firsts, here it is. You're going to multiply the first together. If you do the outers, O. If you do the inners, I. If you do the lasts, it looks like this. That's Mr. FOIL Man. He's got a nose and a mouth, and there he is. So Mr. FOIL Man is what we're going to do to this guy right here. So 2x times 2x gives you a 4x squared. Outers, 2x times -1 is a -2x. Inners, -1 times 2x is another -2x, and -1 times -1 is a +1. Distribute this negative. You've got minus 2x. You've got +1. That's the mistake that is most common in this guy. So I have a -1 made it +1 plus another 1, combined like terms. Woo. Here we go. -2x is -4x, and another -2x gives me -6x. My final numbers are 1, 1, and 1, so I've got 3, and that is my output from that particular function. All right, the last thing was all about calculators. We're going to come back to that and use Desmos in a couple minutes, okay? So we're going to skip over the bottom. So questions up until the first page here. Anything on the first page? Cool. All right, so we're going to the second page, and now they want to show you that there's 3 different ways that you can write a coordinate. You can either use a table, you can write it as an ordered pair, like an xy value, or you can write it in function notation where this is your x value and this is your y value. They all mean the same thing. So mean the same. It's just 3 different ways of writing it. So you've got a choice in the matter on that. For the next thing he was trying to put into words, depends on is equivalent to saying is a function of. And so he decided to give you an example here. The number of gray hairs on Mr. Bruce's head is a function of the number of students in his Algebra 1 class. It's the same as saying the number of gray hairs on Mr. Bruce's head depends on the number of students in his class. So if you take the g function where s is the number of students, this is important, in Mr. Bruce's Algebra 1 class, and g of s is the number of gray hairs, they're the 2 things that we're looking at, I've got to decide what these numbers represent. So this number in the parentheses is actually the students, G of S, S is students. And when the students are 14, he's got 513 gray hairs. And so that's what he said on this one. So when there's 14 students in Mr. Bruce's class, he has 513 gray hairs. And the same thing goes over here, it just changes your numbers a little bit. If there's 27 students, then he's got 2,088 gray hairs. And so he kind of explained all that as well. And then the last piece, before we get into examples and new stuff, is something called the vertical line test, the VLT I call it, the VLT, because there's also an HLT, horizontal line test, which tells you something totally different. This one tells you, determines if it's a function or not. And the deal is a vertical line can only cross through the graph in one place for the entire graph. So if I'm looking at this first one, this one's cool right here, no issues right there, right? It crosses through in one place. But then I start walking around the graph and then I get over here and I'm like, whoa, Nelly, you're going through in 3 different places. That's not cool. So this guy's not a function. So he's not. This guy, if I start drawing vertical lines for him, he's cool. Everything's good. So he's a function. Crosses through once. Circle crosses through twice. He's not a function. This guy here is the square root graph. That's what the square root graph looks like. And if I do my vertical line test, he passes, so he's a function. If I go here, this is either the sine or the cosine graph, one or the other, that wavy kind of thing, and he would pass the vertical line test, so he's a function. And then I get to this piecewise guy. They're a little more tricky because I got to actually look at how a vertical line is going to go through in these certain places. Like if I'm right here and I start going a vertical line through there, it doesn't touch here, it does here. So I've got it only going through in one place. So that works. I keep going along. He's fine, he's fine, he's fine. Vertical lines, vertical lines. But I get over here and you see this is a little tricky. I didn't catch this at first. It actually goes through in 2 different places because between 1 and 2, the graph actually has 2 different locations. So I've got a point up here and a point down here, and that would fail. So this guy is not a function. All right, so questions on anything from the video? You can see I kind of went through that fast because obviously I'm assuming that you've seen the video and you're good to go. All right, let's go to Desmos. Let's go back to our first page and let's pull up. I'll give you a second to grab your Desmos, and I'm going to do the same, and then I'm going to share my screen.
Are we just going to the graph?
Yeah, you're going to, yes, so if you open up Desmos and go to the graphing calculator,
Okay.
you should get this picture, right?
Okay, yeah, I have that. Thank you.
Mm-hmm. I'll take a pause for a second. Sip a coffee while you get your Desmos. All right, so you're putting in y equals, if it'll let me, there it is, y equals 3x squared. I'm at the bottom of the first page of notes. Minus 0.2x plus 37. Also, while we're putting that in case we had anybody that came in late, make sure that you have answered my morning question of something that went well this week, a positive of this week, and something that maybe you wish had been different about this week so that I can take roll. So make sure you've answered in the chat those 2 questions. All right, so I graph it and I'm like, where is it? Right? Where did this thing go? And he showed you too, most graphs when you see them on the calculator or on Desmos, they go between -10 and +10, both horizontally and vertically. So we have a 37 going on in this guy, which means that we need to take ourselves, oh, there he is. We need to actually zoom it out so that we can see where the graph is. Now, it's a squared graph, so it's a parabola. It's a positive 3 in front. That makes it a happy parabola, just like it is right there. He's skinny. He's a skinny mini. And so we have it graphed, and on the calculator on the video, he showed you several different ways for you to be able to to verify different values. What we're going to do is use a table. Now, just hang in there for a second. I used this plus sign. I actually took and went down to the next thing, and I used a plus sign, and I went to table. And that's how I taught this lesson to the regular pre-calc kids yesterday. But I had someone who was so brilliant, and he told me that you can go here to the table. Did you catch what I just did? Let me go back to this scrolly thing, the circle there, the edit list. If you press on that and press table, it automatically generates a table for you, which is way easier than the way that I was trying to do it. So I was so excited to learn that yesterday. And all you're doing is plugging in the numbers. So we want to know what f of 2 is. You plug a 2 in, you get 48.6. You have a negative 3.4. Oh, hold on. Negative 3.4. That gives you 72.36. And the last one you have is 107. And that gives you 34,362.6. So a real easy way for you to be able to evaluate those using Desmos rather than, and look, it even put the points on our graph to give them a location. All right, again, I'm going to stop for a second, take questions. Anybody?
I have a question.
Yeah, Loa.
What was the thing I put in the chat?
Oh, we're all over the place. Okay, so in the chat, I want to know, this was our first week of crazy virtual learning, right? Crazy week of school. I want to know one thing that went well for you and one thing that you wish had been different. So like a positive, and I don't want to necessarily say a negative, but what was good and what wasn't. Okay? All right. What we're going to do next is get into the actual examples. So this is now new stuff. If you watch the video, what I've said so far is nothing new. All right, so I'm going to take away my Desmos for now and go back to the practice problems. All right, so on the practice problems, can you see, give me a thumbs up if you can see the practice page. Thumbs up, okay, thank you. All right, I'm going to pick and choose. These are the 1 to 24 that you have to do and turn in. I'm going to pick and choose like one or two from each section so that you kind of have a clue as to how to do each type. So I'm going to pick and choose, and then we're going to go through the practice problems here. So first one is identify the relationship, if the relationship is a function or not, and if it's not, tell why. All right, so I'm looking at number 1. And number 1 has a negative 2 to 5, 0 to 5, 1 to 5, 2 to 5, 6 to 5, and there are no repeating x's. So is it a function or is it not? Thumbs up, thumbs down. How about middle? I don't know. I got a whole lot of nothing. Oh my goodness. Okay, so if you go back to the first page, it's kind of like this guy. I can have all of my y's are the same, but the x's are all different. So that one is a function. Remember, the rule is that the same x can't give you different y's. And so otherwise, it's going to be a function. So this first one, number 1, is a function. And then I wanted to look at number 3, because number 3 is actually asking you obviously the same thing, but it's put in a different way. It's put actually as a bunch of coordinates. So I've got negative 17, my x gives me 0 for a y. 1 gives me negative 4, negative 2 gives me 5, 3 gives me 4, and 1 gives me 6. So I'm looking to see, do I have any x's that give me different y's? I'm looking. This x is a 1, gives me a negative 4. This x is a 1, gives me a 6. I have an issue. I can't have the same x giving me different y's. So this guy is not a function. They asked you to explain it, and that's kind of what you say. Same x can't give different y's. So that whole first section is all looking at that. If I go to the second section, these now say identify the independent or the input variables and the dependent or the output variables. So if I'm looking at what this one's going to do, I have number 8 that I wanted to look at. So in number 8, it says the month of the year helps determine the average high temperature, and my job is to figure out what the independent variable is and what the dependent variable is. Dependent. So if I'm looking at those two options for this one, I have a situation that's month of the year, and I have an average high temperature. They're my two things that are in my comparison. Sometimes it's easier to figure out what the dependent one, what's changing, what's the one that's variable kind of thing, that's changing as you go along. And that would be what this average high temperature is. It depends on what the month of the year is. So your independent is your months. And the month of the year depends on, the average temperature depends on the month of the year. So this down here is your average temperature. Average high temperature. Okay. Just checking our chats there. All right, next set. I've got number 9 circled. Write a sentence. Now that we have like English class, right? In a math class, what's that all about? Write a sentence explaining the meaning of the specific numbers given for each scenario. So this is kind of like the Mr. Bruce with the gray hairs kind of thing. So we have to write a sentence about this, and it says, the input of a function C is time of day since midnight. The output is the number of cars in a parking lot. What does C of 9 equals 115 mean? So I've got to determine my two things. One is the time of day since midnight, and one is the number of cars in the parking lot. They're the two things that are the comparison. I have a 9 and I have 115, and I've got to figure out what those numbers actually represent. So, any guesses on what the 9's about? Is the 9 the time or the cars? Anybody? You're a talkative group. Time, thank you. I got that in the chat. Thank you. All right, so this is the time. So I know the 9 is the time. That means that the 115 is the number of cars. So let's put that into a sentence. Now, this is the time of day since midnight. If it's 9 hours since midnight, then you're at 9 a.m. So at 9 a.m., my sentence is going to be, and you can write this however, you don't have to use the same exact words that I use, but you want to have the same meaning. So at 9 a.m., there are 115 cars in the parking lot. So there's my sentence. Write a sentence explaining the meaning of the specific numbers given, and there we go. So that's how you're going to do that set. Then we get down, we're going to come back to number 13 because number 13 makes us go back to Desmos to graph that. So we'll come back to that in just a second. If you flip over to the next page, this one now says, this set of problems says, use the graph given for each problem to determine the values. If the value is between two integers, approximate to one decimal place. All right, so we're going to make approximations if it doesn't go directly through where it's supposed to go through. So I'm going to do 16. f of negative 3 equals. Now remember the number in the parentheses, this is your x value. They're asking you for what the y value would be that goes with that. So if I swing along my graph to negative 3, here's negative 3, I'm down here. And so I look and see, approximate that place, and that place would be like a negative 2. So here you go, negative 2. Same thing with B, but now I'm looking at 1.5, positive 1.5. Here's 1, here's 1.5, go down to the graph, I'm down here. Guess what? It's negative 2. But then he switches it up, and this might be confusing for some people. This time, here's the x value. They want to know what the x value is when y, remember this side of the equal sign is the y value, when y is 3. So now I'm looking for the graph the other way. I'm looking at where y is 3. So here, I go up to where y is 3. I swing over to where the graph is, and it's this point over here. Now, if I'm at that point, is that going through directly at 3? It's just slightly off, so we need to estimate. That's where the estimations come in. And you can call it 3.1, 3.2, whatever makes you happy. You need to be in my hood to be good. So somewhere around the 3.2, kind of 3.1-ish area. And then for part D, they say, where are the x's when y is 0? Now when y is 0, that's where it crosses the x-axis. They're actually going to be your zeros on the graph. So I've got 3 of them. I've got 1 here, I've got 1 here, and I've got 1 over here. So I need to estimate about where they are. So what are the x's when y is 0? And I'm going to look and see. X equals, I'm going left to right. This guy's not quite negative 3. Maybe it's an estimation of a negative 2.7. Negative 2.7. This one's going through at 0. He's happy right there. This guy is going through also between 2 and 3, but not quite going through exactly the place, exactly at 2 or 3. So I'm going to estimate again. Maybe you might want to say 2.6. And again, you just need to be in my hood to be good. You just need to be in my neighborhood there, okay? All right, a couple more. This is next set. They want to know, are these functions or not? And so we're looking at number 22 as our next one, because that's kind of one of the harder ones with the piecewise functions. So I want to do the vertical line test. This is all about the VLT, vertical line test. Is it going to go through once? Is it going to go through more than once? So if I look at this, here's the first place I come to that could be questionable. And if I put a vertical line through that, it only goes through in one place because I've got an open circle and a closed circle. So I keep going along, keep thinking about my vertical line, vertical line, vertical line, vertical line. And everywhere else is happy, so this guy turns out to be a function. He passes the vertical line test. All right, 24. Now, the two that I want to look at with you guys are B and C, because they're the hardest ones, of course. If I look at this, let me see. Let me do C with you first, okay? This is actually building a building block going towards talking about something in calculus called derivatives. They're kind of getting into something, if I give you the math gobbledygook language, it's a difference quotient that they're building towards, something called a difference quotient. And it involves this x plus h. H is just this unusual letter that they use in it for now. So this is kind of a building block for somewhere that you're going to go in the near future. So here's your function, 3x squared minus x plus 2, and we're going to plug in x plus h into each of these locations. Now I'm going to flip my paper over so that I have room to write it. So 3x plus h squared, hold on, minus x plus h. Remember to use those parentheses. They're extremely important for us. And then it's a plus 2, right? Plus 2. Now I did the kind of the same type of work when we were doing that first page of notes. But this is going to be kind of very similar. So there's some steps to this. I'm going to come off to the side and I'm going to FOIL x plus h, and I want to see how that looks. So if I have x plus h x plus h. And again, I'm doing, please excuse my dear Aunt Sally, I have to do the exponent first before I multiply by the 3. So don't multiply the 3 into this and then square it. That's no good. No bueno. All right, so for this one, I'm foiling this off to the side. First, give me an x squared. Outers, I have an x and I have an h. They're not alike, but that's okay. xh. Then I have the inners, h times x, and then I have h squared at the end. Now stop me if I lose you in the midst of this, okay? Here we go. My next question is, and I want a thumbs up or thumbs down, are these the same thing? Is hx the same thing as xh? Thumbs up, okay. Thumbs down. We got a combination, cool. All right, so let's have a discussion. Some are saying yes, some are saying no. If I have, here's my question for you. If I have 2 times 3, 6, is it the same thing as 3 times 2, 6? Right, they actually are the same thing, believe it or not. So you're allowed to, it's called the commutative property, you're allowed to change places. But if you think of it with numbers, it makes a lot more sense. 2 times 3 is the same thing as 3 times 2, so we're good. These are like terms, which means that I really have x squared plus 2, take your pick, call it xh, call it hx, whatever. And there you go. Now remember, this is just this part. This now needs to get multiplied by 3 so that I can come back over here and take care of this whole first piece. So here I go. I'm going to distribute my 3 into those and see what it looks like. I have a 3x squared. I have 2 times 3 is 6xh. And I have 3 times h squared is a plus h, 3h squared. Thank God for erasable pens. 3h squared. That takes care of this whole front load. Now I'm to the middle with these parentheses. So distribute the negative, minus x, minus h, plus 2. And you've done the hardest part. Now it's just a matter of combining like terms if there are any. And I'm looking down the line. Ain't no other x squareds, ain't no other xh's, ain't no other h squareds. There is nothing there to combine. That is my final beastly answer right there. There it is. And I do believe that that little box they gave you may not be big enough to put all that stuff in there, but. All right, so here's your challenge. I'm going to give you a problem to try. I want you to do B. I gave you the easier one. See if you can do B. Then we're going to see, I'll do B as well, and we'll see if we match. So take a second and see if you can do 24B. Actually, I'm going to take my paper away so you can't peek. Yeah, Noah.
Classroom somewhere.
I'm sorry, say again?
This document, Google Classroom.
It is, the blank of it is. I was saying at the beginning of class 2 that when I post these, I post them for the whole section. So you'll have the blank document, you'll have the completed document, you'll have the videos that go with it, and so forth. If you can print them out, great. If you can't print them out, then just use loose leaf paper. But if either of those, if you want a copy of the actual notes for the unit, you can let me know that too. Because I can mail you the blanks of the unit. So you have a few options. Either you can print them out yourself, or you can just use regular loose leaf, or you can let me know and I'll mail you the unit's worth. Okay? I'm answering it. Chat real quick. Okay. Here's the hope. Did you get an answer? Or am I going too fast? We ready for an answer? All right, here's the hope. The hope is that you got 3x squared plus 17x plus 26. Are there thumbs up in your hood? Thumbs up in the hood. Woo-wee. Okay. So here's the very last thing I'm going to do with you. I want to go back to Desmos and do that problem that we skipped over, which was number 13. So if you pull up your Desmos in number 13, let me hope I still have mine up. I do. Sweet. Okay, I'm going to X out, but let me share my screen with you. Hang on. I forget that I need to do that. Share my screen with Desmos. Here it is. So here's your story with fractions. This is really, really, really super duper important. You need to keep your numerator in parentheses and your denominator in parentheses, or else it's not going to be written right when you put it in. So if you go back to Desmos and start with parentheses and start with your top, it's x squared and then plus x, close up those parentheses, and then divided by, open a new set of parentheses, and you've got x minus 4. And you should get a picture of something like this. This is a rational function. It's called a rational function. We're going to study those later in the year. They've got all sorts of cool stuff going on. This particular one has a vertical asymptote. You can kind of see that vertical line there that it comes really close to but doesn't touch. Have you talked to asymptotes? Is that a new word to you? It's a new, okay. So there's these funky things called asymptotes. And they are lines that the graph gets really close to but never touches, which is really kind of interesting. So there's a vertical line here in this one. There's also a slant asymptote in this particular one. But anyway, you're going to make a table of values for where we're at right now. You're going to make a table, and you want to put in a -5. And I'm looking at number 13. You want to put in a 5.1. And you want to put in a 21. And there's your values. So real simple with that again. Okay, so we have class again on Tuesday. These problems are due, have I put a due date on these? I shouldn't be asking you, I should know that already, right? Anyway, I believe these are due on Monday. Maybe I didn't because I haven't done your next week's thing. All right. Anyway, these need to be done on Monday, and I also need you to watch the video for 2.2 because we're going to start section 2.2 on Tuesday when we have class again. So the two things you have coming at you that are due. The first one is to complete 1 through 24, and what you're going to do is I'm going to stop sharing my screen and go back to the regular. What you're going to do is when you finish them, you're going to either send me a picture of them, email me a picture of them, or you can, it says they're due today. Woo. Thanks, Noah. I'm okay with them being in by Monday. Okay, so it's not, I just want them done before we start the next section, right? That's what logically should happen. So if you want to turn them in today, great. If you can see they're not going to take that long to complete the rest of them. If you want to turn it in by Monday, that's okay too. So for class Tuesday, the two things that I want you to have done are these, 1 through 24, which again, you can take a picture and send me an email of the picture, or you can do a picture and post them on our classroom page. If you can't take a picture of them, shoot me an email and we'll figure something out. Maybe we'll Zoom and you can just show me over Zoom or something like that. Okay, so we'll figure out an alternate way if you can't send me a picture. So two things for Tuesday, again, 1 through 24 of section 2.1, and make sure you watch the video for 2.2 on domain and range. And then we'll pick up from there on Tuesday when we meet again. So questions from your end, anybody?
I have a question.
Yeah.
So, is there a way that you can email me, like, all of the unit that I can print out?
Instead of grabbing them from the classroom page,
Yeah.
I can absolutely, and this is Bella, right? I'm just going,
Yeah.
okay. I will write myself a note. Hang on. Note paper. There was somebody else, Bella, too, that I was talking to recently that they couldn't do them from the classroom page, but they could from an email. So I will do that. Anybody else having an issue that would like to figure out a way to get notes? Okay, so email me if you have any questions on any of the problems. Email me if you need the note packets for the unit, or anything else that I can do to help you out. I appreciate your chat things today. It was very interesting to read what you ran into for problems and what you ran into for successes for the week. And I look forward to seeing you again on Tuesday, all right? You guys have a great weekend. Woo, weekend, it's Friday. All right, I will see you Tuesday.